So one of the things that we want to use properties of logarithms for is to take a logarithmic expression that's rather large and has multiple logarithms in it, and to express it as a single logarithm, okay? And so here we have one that has three logarithms. Here's a logarithm, here's a logarithm, and here's a logarithm. Now they all have to be the same base, and they are natural log, and natural log. What I'm going to do in this particular example is step by step, we're going to use the properties of logarithms to change this expression into so that it is a single logarithm, so that it only has a single natural log. Now, do you see this 3 times the natural log? Now remember, the property, the exponent to multiplication property, says that if we have a number that's being multiplied on the front of a logarithm, we can move it inside the logarithm as an exponent on whatever is inside the logarithm. So we can, this 3 right here is actually an exponent on 2. And so we can rewrite this as the natural log of 2 to the third power, okay? So this and this mean the exact same thing by the properties of logarithms, okay? Now we're going to put plus. Now we're going to do the same thing here. This 5 is going to be an exponent on 3, so we're going to write the natural log of 3 to the 5th power, okay? Then we're going to put a minus, and then here we're going to do the same thing. This 7 is going to become an exponent on this 4, so it's going to become natural log of 4 to the 7th power, okay? Now we're not going to expand these. We're not going to make this an 8, at least not in this example. We're not going to make this an 8. This would be pretty big. It's 3, oh no, this one 243 is that one. But 4 to the 7th is pretty huge, so we're just going to leave that as 4 to the 7th, okay? All right, so this addition here, if we just look at this, okay, this is telling us that we can combine these into a single logarithm where it's addition between, but if we make it a single logarithm, it'll become 2 to the 3rd power times 3 to the 5th power, okay? So we're going to condense this into a single logarithm, which is now going to be the natural log of 2 to the 3rd power times 3 to the 5th power, okay? And then we're just going to carry down this minus the natural log of 4 to the 7th power, okay? And now this minus means division, that we can combine this logarithm and this logarithm into a single logarithm, okay? So they can become a single logarithm, the natural log of, and now it's going to be this divided by this. So 2 to the 3rd times 3 to the 5th in the numerator and 4 to the 7th in the denominator. Okay, so it'll be 2 to the 3rd power times 3 to the 5th power divided by 4 to the 7th power, and that is the end. So this is our final answer, a single logarithm. We have taken a logarithmic expression here, and we've condensed it down into a single logarithm. We're going to do another example like that. All right, this one's a little crazy because it's got a fraction. That's okay, and it has these parentheses, these extra parentheses. Okay, so here's what I'm going to do. The first thing I'm going to do is I'm going to combine these two because they're inside parentheses. So it's addition, so it's going to become a single logarithm, and it's going to be a times x. So the addition is going to become multiplication. It's going to become a times x, okay? And so this is 1/2 times, well actually I don't need the parentheses anymore because it's going to become a single logarithm. It'll become 1/2 log of a times x. I'll just write it as ax. There we go, okay? And then this, and then I'll put a minus here, minus. But see this 2 times log of w? I'm going to put the 2 as an exponent on the w because remember, a number on the front can become an exponent on the inside, okay? So this is going to become log of w squared. There we go, okay? And now what I'm going to do is, before I deal with this subtraction, I want to put this 1/2 as an exponent on the ax. Now, let me write it out first. So I'm going to write log and then I'm going to put parentheses around the ax, and then put the 1/2 power on the outside, and then close the logarithm, okay? Then we'll have minus log of w squared, okay? Now what is a 1/2 power? I want to remind you that a 1/2 power means a square root. So like, 7 to the 1/2 power is the same thing as the square root of 7. So ax to the 1/2 power means the square root of ax, okay? So this is going to become the square root of ax. So we're now going to have log of the square root of ax minus log of w squared. Now we're going to do the last step. This subtraction means division. So we can do a single logarithm with this in the numerator and this in the denominator, okay? So it's going to become log of the square root of ax in the numerator over w squared in the denominator, and this is the end. That's our final logarithm, a single logarithm from an expanded logarithm. Okay. Now what we're going to do is we're going to do some expanding of single logarithms. Okay, in this example we have a single logarithm and we're going to expand it into multiple logarithms. How many logarithms are we going to have? Well, we want a logarithm for every base within the logarithm. So we have b to the 3rd power, that's one logarithm. C squared is another logarithm, and d to the 11th power is going to be another logarithm. So this is going to wind up with 3 logarithms, okay? All right, so let's see here. Let's start with, let's break apart the numerator from the denominator, okay? So let's do the natural log of just the numerator, okay? So natural log of b to the 3rd power, okay? And now the denominator, we're going to keep it together for now. We're going to break it apart in a few minutes, but we're going to keep it together right now. We're going to do the natural log of the denominator, but remember, because it's division, we have to subtract. So we're going to do minus the natural log of c squared d to the 11th power, okay? All right. Now what we're going to do is, for this logarithm, well, you know what? Let's leave this one alone for now. Let's just look at this one. We want to break apart this logarithm because we have c squared times d11. There's going to be addition between these two logarithms, but because we have a minus here, we're going to have to put this inside parentheses. Okay, and so we're gonna, so anytime you subtract addition, you have to put it inside parentheses. So we're gonna wind up with the natural log of b to the 3rd power minus then big parenthesis. Then we're gonna do the natural log of c squared, natural log of c squared, plus, because we have multiplication here, plus the natural log of d to the 11th power. Okay, there we go. All right, we're getting there, almost done. I think only one more step, actually. Now, for each one of these, for b, we have the 3rd power, for c, we have the 2nd power, and for d, we have the 11th power. We're going to take these exponents and we're going to move them to the front of the logarithm, okay? So this is going to become 3 natural log of b, and this is what we want. We want to have the natural log of just the letter. We don't want anything with it, and we don't want it with other things either, okay? Then minus, then parenthesis. Now in this one, we're going to take the 2 and move it to the front. Okay, so we're going to have 2 natural log of c plus. Then on this one, we're going to move the 11 to the front. So we'll have 11 times natural log of d. Close off that last parenthesis, and we're done. This is our expanded logarithm from this single logarithm. All right, we're going to do just one more example. Okay, this one's a little crazy. Why? Because it has the radical, and that's going to scare you off, but it's actually really easy. The good news is all of our exponents are even, so we're going to resolve this radical pretty fast. Okay, why don't we start by converting the radical into a 1/2 power, because remember, the square root means the 1/2 power. So we're going to rewrite this logarithm as log of, inside parentheses, we're going to put x to the 4th y to the 6th over z to the 8th. And then on the outside of that, we're going to put the 1/2 power, and then we're going to close off the logarithm, okay? Now what we're going to do is we're going to distribute the 1/2 power to the 4 and to the 6 and to the 8. And what we have to do is we have to multiply these. We have to do 4 times 1/2, then 6 times 1/2, then 8 times 1/2. Well, 4 times 1/2 is 2. So this logarithm is now going to become, it's going to become log of x. Now 4 times 1/2 is 2, so this will become x to the 2nd power. Then y to the 6th, 6 times 1/2 becomes 3. So this will become y to the 3rd power over z to the 8th, 8 to the 1 or times 1/2. 8 times 1/2 is 4. So this will become z to the 4th power. Okay? All right, so now this is a lot easier to do. This one looks like our last example. So now we're going to break it apart. We're going to do log of the numerator. So we're going to do log of x squared times y to the 3rd. Okay, good. And then we have the denominator. We're dividing, and so that the division is going to become subtraction between logs. And notice we have 1, 2, 3 letters. So we're going to have 3 logarithms. Okay, so divided by, so we're going to have minus log of z to the 4th power. Okay. Now this can be broken up into 2 logarithms. We have multiplication happening here, so it'll become addition between 2 logarithms. Okay, so we'll have log of x squared plus. Now you may say, why did I not put a parenthesis on the front? Well, there's no subtraction out here in the front. Okay, there's nothing over here, and therefore we don't have to group it. Okay, so this will be log of x squared plus, remember the multiplication is becoming addition between, plus another log of y cubed. Then we'll put on the minus log of z to the 4th. Okay? And so now we're going to deal with these exponents, the 2 and the 3 and the 4. And so this 2 is going to go to the front of the logarithm, and so we'll have 2 log of x plus this 3 will go to the front of the logarithm, and so we'll have 3 log of y minus, and this 4 will go to the front of the log, and it'll be 4 log of z. And so here we have our expanded logarithm from this single logarithm.